A single crazy decision in 1995 changed everything we thought we knew about the universe. Robert Williams, director of the Space Telescope Science Institute, pointed the mighty Hubble Space Telescope at a completely empty-looking patch of sky and left it there for 100 long hours. His colleagues called it madness. They said he was throwing away precious telescope time on nothing. Williams answered with fire. If nothing amazing appeared, he would resign on the spot. Between December 18th and 28th, 1995, Hubble stared at a tiny dark spot near the handle of the Big Dipper, a spot only 1/30th the width of the full moon. The telescope clicked 342 separate pictures, each exposed for 25 to 45 minutes. When scientists finally stacked all the images together, their jaws dropped. That empty patch exploded with more than 3,000 galaxies. Some of them were born 12 billion years ago. Spiral galaxies, elliptical galaxies, lenticular galaxies, red ones, blue ones, orange and yellow ones, every shape and color poured out like treasure from a broken chest. The picture became famous as the Hubble Deep Field, the deepest portrait of the universe ever taken until then. Almost 30 years later, the world waited for something even greater. The James Webb Space Telescope, a $10 billion miracle, finally started its real science work in mid-2022. In its very first year, two small programs pointed Webb at tiny pieces of sky. Just like Hubble had done, everyone expected a slightly better version of the old pictures. Nobody was ready for what actually happened. Within days, galaxies from the baby universe jumped into view. These were not small baby galaxies. These were monsters, bright giants that lived only 200 to 300 million years after the Big Bang itself. Astronomers rubbed their eyes in shock. According to every textbook, galaxies needed almost 1 billion years of slow growth to become that big and that bright. Yet here they were, shining like grown adults in the cosmic nursery. One of them, named GLZ13, sits at redshift 13.1. That means we see it as it was just 300 million years after the Big Bang. It already weighs 1 billion times the mass of our sun. No known law of star birth can explain how so many stars form so fast. Even if every bit of gas in that young universe turned into stars at maximum speed, it still would not be enough. Something was very wrong with the old story. Scientists began to sweat. The standard picture said the early universe should be full of tiny building blocks, little proto-galaxies still waiting to merge. Instead, Webb showed a sky already ruled by huge, mature galaxies. The old timeline was broken. The James Webb Space Telescope just punched a giant hole in everything we thought we understood about the dawn of galaxies. Bright, massive galaxies appeared far too early and far too big. Our favorite model, called lambda cold dark matter lambda CDM, says the universe grew slowly and carefully. First came tiny seeds made of hydrogen and helium, round invisible dark matter. These seeds crashed together over hundreds of millions of years to build bigger galaxies. Webb says no. That story is too slow. Scientists are now racing to save or fix the model. Some say star formation was super efficient in the hot, dense early universe. Others say strong magnetic fields appeared earlier than expected and pushed gas together faster. A simpler idea is that young galaxies had almost no dust, so they looked extra bright in Webb's infrared eyes. Every team is trying hard to make the new observations fit the old rules. A few brave voices whisper about something more radical. In 1983, a physicist named Mordechai Milgram proposed MOND, modified Newtonian dynamics. MOND says dark matter does not exist at all. Instead, gravity itself behaves differently on very large scales. Some of Webb's strange galaxies line up better with MOND than with dark matter. The idea, once laughed at, suddenly has new life. But no one is ready to throw away the Big Bang itself. That theory is too strong. It correctly predicts exactly how much hydrogen, helium, and lithium were cooked in the first minutes after the bang. When we look at the oldest stars, the amounts match perfectly. It predicts that distant galaxies run away from us, stretching their light to redder colors. And that is exactly what we see. Most powerful of all, it predicted a faint glow left over from the hot beginning, the cosmic microwave background. Discovered in 1965, the Big Bang is safe for now. What really needs fixing are the details of how stars and galaxies grew up. Webb's first deep looks already forced scientists to rewrite the chapter on the universe as teenage years. Soon, a giant new program called Cosmos will stare at a much wider piece of sky for hundreds of hours. Astronomers expect to find thousands more of these impossible early galaxies. With better numbers, the true story will become clear. Some scientists dream Webb will reach redshift 20 or even 26, showing us the universe when it was only 120 million years old. If that happens, every textbook will have to be rewritten from the first page. The infant universe was wilder, faster, and more brilliant than anyone dared imagine. One risky photograph in 1995 opened our eyes. One golden telescope in 2022 and beyond is rewriting the birth cry of everything. The universe is far more surprising than we ever guessed, and the show is just beginning.